Good morning, Year 5, and welcome to your maths lesson for Monday. We are going to carry on having a look at adding fractions. And today we're moving on to adding 3 fractions. So it's going to be using the same principles that we've looked at already, but applying it to an extra fellow in there. So let's have a look first of all at our starter activity. So you need to complete these equations. So 5/16 plus something eighths equals 15/16, and something 20ths 7/10 equals 17/20. Can you have a little go at finding equivalent fractions to complete those equations? And then when you've done that, come back to me and let's have a look and see what the answer is. Okay, so we can see that the denominators aren't the same. So we need to find an equivalent fraction where the denominators are the same so that we can solve this sum. That means that we need to get 8 up to 16, which we can do by multiplying it by 2. Now, this also means that the numerator will have to be multiplied by 2 when we know what it is. Now, 5/16 plus something equals 15/16. This fraction is going to have to be the equivalent of 10/16. Now, I know that I'm multiplying 8 by 2, so that means I need to use the inverse and divide 16 by 2 to get it to 8. So I need to do the same for the numerator, and 10 divided by 2 is 5. So 5/8 fills in our gap there. That beautifully drawn 5, Mr. Benson, well done. The next one, we know again that I need to change the denominator so that they are equivalent, and I'm going to have to do the same to the numerator. So 7/10 is the same as 14/20, which means that we need to add 3 more. So we need 3/20 there. That one was significantly better. So let's have a look and see. So we are adding fractions again. There are our key words for today. Let's have a reminder of what we need to do to add 2 fractions. First of all, here we've got 2 fractions. How can we add them together? Because the denominators are different, we can't just add the numerators together. We need to find an equivalent fraction so that the denominators are the same. So let's have a look and see what we can do. We're going to go through our 3s and our 6s. And if I have a look and see, I think my face might be in the way there, but the lowest common multiple is 6. So I don't need to change my 6ths. They already have 6 as the denominator, but I need to multiply 3 by 2 to get to 6, which means I need to do the same to the numerator. 2 times 2 equals 4. So I've got 4/6, add 4/6. Now the denominators are the same. I just need to add the numerators together, which gives me 8/6, or the same as 1 whole and 2/6. Now I can even find an equivalent fraction there because they can both be divided by 2, so it's the same as 1 and 1/3 as well. So what if we have 3 fractions? So here I've got 1/3 plus 2/5 plus 4/15, and there are their visual representations. Now immediately we have the same problem that we had last time, that the denominators aren't the same. And even if there's 3 fractions, to be able to add them, we need all 3 of them to have the same denominator. So instead of just having 2 lots of times tables to go through, this time we've got 3 lots of times tables to go through. So I've got my 3s, my 5s, and my 15s. Now, if I have a look through them and scan them, I can see that the lowest common multiple is 15. Now, that means that I don't need to do anything to the 15ths. My 3rds, I'll need to multiply by 1, 2, 3, 4, 5. And my 5ths, I'll need to multiply by 1, 2, 3 to change that. So 1 times 5 is 5. 2 times 3 is 6. So I'm left with 5/15 and 6/15. As you can see, in my representation there, they are the equivalent fractions of 1/3 and of 2/5. So now they are all, they all have the same denominator. All I need to do is add them together. So I'm going to use my number bond knowledge to help. 6 add 4 is 10. Add the 5 gives me 15/15, which is also equivalent to 1 whole. It's always important for us to remember what the original sum was as well. So we have to remember that 1/3 add 2/5 add 14/5 is the same as 15/5. Now let's have a look at another one as an example. So this time we've got 3/5 plus 4/10 plus 6/20. There. Oh, no, let me show you the physical visual representations of them first. So here I've got 3 out of 5. Here I've got 4 out of the 10. And finally, 6 out of the 20. Now, these ones I tend to struggle with because if I don't get the middle, then I end up accidentally changing the outline to yellow instead. 1, 2, 3, 4, 5, 6. There we go. Now we can see that the denominators are not the same. So the first thing that I need to do is find same denominator so I can find some equivalent fractions. Now I know that 5 and 10 both go into 20. So I'm going to do that. I'm going to use 20 as my common denominator. I need to times 5 by 4 to get to 20. So I need to do the same to 3. I need to times 10 by 2 to get to 20. So I need to do the same to 4. So I can see that 3/5 is the same as 12 over 20 because 3 times 4 is 12. 4/10 is the same as 8 over 20 because 4 times 2 is 8. And 6/20 does not need to change. So there is my eventual sum that I'm going to do. Now that the denominators are the same, all I need to do is add the numerators together. So 12 add 8 is 20, add 6 is 26. So it's the same as 26 over 20 or 1 whole and 6/20. Yeah, so let's have a look at your activities for today. So if you are on scaffold number 1, this is your job. So you need to use the bar models to complete the sum. The bar models have been done for you. So if I have a look here, I've got 1/2, 1/4, and 1/8. I have turned them all into their common denominator, which in this case is 8ths. Half is the same as 4/8. Quarter is the same as 2/8. An 8 is already 1/8. So I can see here I've got 1, 2, 3, 4, 5, 6, 7 eighths altogether. So 1/2 plus 1/4 plus 1/8 equals 7/8. That is for challenge numero uno. If you are going for challenge deux, very much changing my languages here. The same that we sort of looked at last week, where you've got the same activity, but basically you have to complete the bar models. So if I've got 1/2 here, then I will fill 1 out of the 2, and then I can see that 1/2 is equivalent to 4/8. 1/4. Ooh, I'm going to do it. There we go. No, I'm going to use a different color here just because I like having a different color on the end so I can see. Why are you doing this to me, computer? There we go. And I can see that 1/4, don't you just love technology? 1/4 is the same as 2/8. And then 1/8, I will highlight just that one in a different color. So that means I need to add 4/8, add 2/8, add 1/8, and I can see that that is going to give me 7/8. Yes, I did use the same question, but it's still useful for you guys to see how it's done depending on the scaffold you have. And finally, if you are going for the spicy challenge number 3, you haven't got any of those bar models, you need to have a go at using your knowledge of equivalent fractions. So here I know that it's going to be 8 that is the common denominator. So I'm going to pop a text box in. 1/2 is the same as 4/8 because I need to times both of them by the same thing, and that is 4. 1/4 is going to be the equivalent to 2/8. And then I've got 1/8 left over. So 4 plus 2 plus 1 gives me 7 as well. There are your jobs. Please do take your time with these. It's really important to get that understanding. And sometimes with fractions, if we lose it further back, then it can be quite tricky to get it back. So really take your time. Do the one that you are comfortable with. If you're doing activity 1, brilliant, but do make sure that you are going through and looking at each step that's been done already. Don't just count the boxes at the end, otherwise you won't have that understanding. Good luck, guys, and I look forward to seeing how you get on with this.